Good day all. Today we are going to discuss about the topic independence. Let's start. Show that if two events A and B with the probability of A greater than 0 and P of B greater than 0 are mutually exclusive, they cannot be independent. Okay, here A and B are two events with the probability greater than P of A greater than 0 and P of B greater than 0 are mutually exclusive. You have to show that they cannot be independent. Okay, എയും ബിയും രണ്ട് മ്യൂച്വലി എക്സ്ക്ലൂസീവ് ഇവൻറ്റ്സ് ആണ്. പ്രോബിലിറ്റി ഓഫ് എ ഗ്രേറ്റർ ദാൻ 0, പ്രോബിലിറ്റി ഓഫ് ബി ഗ്രേറ്റർ ദാൻ 0 ആണ് നമ്മൾ പ്രൂവ് ചെയ്യേണ്ടത്. ഇത് ഒരിക്കലും എന്താവത്തില്ല, ഇൻഡിപെൻഡൻ്റ് ആവത്തില്ല. ഓക്കെ, given that A and B are two events, probability of A greater than 0 and probability of B greater than 0, and we assume that they are mutually exclusive. What do you mean mutually exclusive? Mutually exclusive means probability of A intersection B is equal to 0. Probability of A intersection B is equal to 0. Okay, this is the condition of mutually exclusive. If A and B are two events are said to be mutually exclusive or disjoint events, probability of A intersection B is equal to 0. Okay, if but here probability of A into probability of B greater than 0, because probability of A greater than 0 and probability of B greater than 0. So probability of A into probability of B greater than 0. If A and B are independent, the condition is probability of A intersection B is equal to probability of A into probability of B. Okay, probability of A intersection B is equal to probability of B. Here probability of A intersection B is equal to 0 because A and B are mutually exclusive events. So 0, and here probability of A greater than 0 and probability of B greater than 0. Here probability of A into probability of B greater than 0. Okay, probability of A into B greater than 0, that is here probability of A intersection B not equal to probability of A into probability of B. So A and B cannot be independent. Okay, next, show that two events A and B which are independent cannot be mutually exclusive if P of A greater than 0 and P of B greater than 0. Given that probability A and B are independent. A and B are independent. A and B are independent means probability of A intersection B is equal to probability of A into probability of B. Okay, here probability of A greater than 0, probability of B greater than 0, that is probability of A into probability of B also greater than 0, that is probability of A intersection B greater than 0. Okay, if A and B are mutually if A and B are mutually exclusive or disjoint events, A probability of A intersection B must be 0. Okay, if A and B are mutually exclusive events, probability of A intersection B is equal to 0. But here probability of A intersection B greater than 0. Okay, here probability of A intersection B greater than 0. Therefore, A and B cannot be mutually exclusive. Okay, if two events A and B are mutually exclusive with the probabilities of greater than 0 but it cannot be independent. Also two events A and B are independent which cannot be mutually exclusive. അതായത് രണ്ട് ഇവൻറ്റ്സ് എയും ബിയും മ്യൂച്വലി എക്സ്ക്ലൂസീവ് ആയാൽ അത് ഒരിക്കലും എന്താവത്തില്ല, ഇൻഡിപെൻഡൻ്റ് ആവത്തില്ല. അതുപോലെ തന്നെ രണ്ട് ഇവൻറ്റ്സ് എയും ബിയും രണ്ട് ഇവൻറ്റ്സ് ഇൻഡിപെൻഡൻ്റ് ആണെങ്കിൽ അത് ഒരിക്കലും എന്താവില്ല, മ്യൂച്വലി എക്സ്ക്ലൂസീവ് ആവില്ല. കണ്ടീഷൻ ഇഫ് പ്രോബിലിറ്റി ഓഫ് എ greater than 0 and probability of B greater than 0. Okay, and next, if theorem, okay, this theorem, if A and B are independent, then A and B complement are independent, and second A complement and B are independent, and third A complement and B complement are independent. Okay, look here, given that if A and B are independent, that is, if A and B are independent, if A and B are independent, the condition is probability of, if and only if probability of A intersection B is equal to probability of A into probability B. Here, given that A and B are independent, then we have to prove that A and B complement are independent. A and B complement are independent. Okay, we know that the multiplication theorem of two events, that is probability of A intersection B is equal to probability of A into probability of B given A. Okay, this is multiplication theorem of two events. And also, if A and B are independent, probability of A given B is equal to probability of A, and probability of B given A is equal to probability of B. Okay, here A and B complement are, we have to prove that A and B complement are also independent, that is probability of A intersection B complement, we have to prove that probability of A intersection B complement is equal to probability of A into probability of B complement. Okay, here A and B are independent if and only if probability of A intersection B is equal to probability of A into probability B. So, if A and B are independent if and only if this condition is satisfied, then we say that A and B are independent. Here, you have to prove that A and B complement are independent. So, the condition is probability of A intersection B complement is equal to probability of A into probability of B complement. Here, we can write probability of A intersection B complement is equal to, that we know that probability of A intersection B is equal to probability of A into probability of A given A. Therefore, like this, you can write probability of A into probability of, instead of B, here B complement given A. Okay, that is equal to, we know that, okay, P of A into, we know that probability of A complement is equal to 1 minus P of A. Okay, so here P of B complement given is written as 1 minus, here P of A complement is equal to 1 minus P of A. Instead of A complement, here B complement given A. So, you can write P of 1 minus P of B given A. Okay, that is equal to P of A into, we know that A and B are independent. So, if A and B are independent, probability of B given A is equal to P of B. So, 1 minus probability of B given A is written as probability of B, because A and B are independent. Okay, is equal to P of A into 1 minus P of B. That is 1 minus P of A is P of A complement, then 1 minus P of B is P of B complement. Okay, hence the proof. Okay, P of A intersection B complement is equal to P of A into P of B complement. Therefore, A and B complement are independent. Okay, then we have to next theorem. A complement and B are independent. Okay, A complement and B are independent. If A and B are independent, then A complement and B are independent. Okay. That is, we have to prove that A complement and B are independent. Okay, B are independent. Here we have to prove that A complement intersection B complement is equal to P of A complement into P of B. Okay. Here P of A complement intersection B is equal to, we can written as like this, that is P of, that is we can written as that is P of B intersection A complement. Okay. Okay, then is equal to, instead of B here, instead of A here B. Okay, so probability of B into here we can written as probability of A complement given B. Okay, and is equal to probability of B into, we know that probability of A complement is equal to 1 minus of P of A. So we can write 1 minus, instead of A complement here, A complement given B, that is 1 minus P of A given B. So probability of B into, given that A and B are independent, therefore probability of A given B is equal to P of A. So 1 minus P of A given B written as P of A, that is 1 minus P of A, that is equal to P of B into 1 minus P of A. 1 minus P of A is P of A complement. Okay, that is P of A complement intersection is equal to P of B into P of A complement. So this theorem is proved. Okay, and next we have to prove that probability of A complement and B complement are independent. Okay, probability of A complement and B complement are independent. That is equal to, we have to prove that A complement and B complement are independent. Okay, independent, that is probability of A complement intersection B complement intersection. Okay, intersection B complement. Okay, that is probability of A complement intersection B complement. Okay, is equal to, we can by the multiplication of two events we can write as like this. Okay, that is probability of A complement into probability of what, B complement given A complement. Okay, that is equal to P of A complement. We know that P of A complement is equal to 1 minus P of A. We can written as probability of 1 minus probability of B given A complement. We can already prove B and A complement are independent. Okay, B and A complement are independent. Okay, so probability of A complement into, we already proved that B and A complement are independent. Using this we can write 1 minus P of B. Okay, that is P of A complement into 1 minus P of B is P of B complement. Okay, hence the proof. Okay, if A and B are independent, A complement and B complement are also independent, A and B are independent, and A complement A and B are if A and B are independent, A complement and B are also independent, B complement and A are independent, A complement and B are independent, and A complement and B complement are also independent. Okay, so